is Ulf Bang, and today I'm going to tell you a bit about the updates we are releasing in this September 2022 version of SystemairCAD called H4. This video is about the temperature increase in the fan section. As something new, we are estimating the load on the fan and calculate the resulting temperature increase in the fan section. It is business as usual if we are talking about a standard configuration like the one I'm showing on the screen right now. Here we will have, for example, in the wintertime, 14.6 degrees leaving the rotary heat exchanger. Then the temperature will increase with, let's say, half a degree in this example in the fan section. That means that the entering temperature will be 15.1 in the heating coil section. Then the heating coil will heat the air up to the required 22 degrees that we would like to have in the supply air. In the summer situation, we maybe get, with cooling recovery, 23.9 degrees coming from the rotary heat exchanger. That will be heated to 24.4 in the fan because we still have this half a degree temperature difference. And then it will enter the cooling coil with the 24.4 and cool down the air to 16. So we actually get a little less capacity on the heating coil, but more capacity on the cooling coil because we add this half a degree in the fan section. If the coils are placed in front of the fan, then it's a different situation. Now we can define the supply air temperature as the temperature after the heating coil or after the cooling coil in summertime, because the fan will add this half a degree. Load is the same as the previous example, so this will add half a degree. So if we again have the 14.6 degrees leaving the rotary heat exchanger in wintertime, then we have 14.6 entering the heating coil, but we only have to heat it to 21.5 because the fan will add the last half a degree. So we will once again have 22 degrees in the supply air. In summertime, we once again will have the 23.9 leaving the rotary heat exchanger. Same temperature going into the cooling coil. But now we need to, what can we say, sub-cool it a bit because we will add half a degree. So if I want 16 degrees supply air, then I actually need to cool down to 15.5 because I will increase the temperature by half a degree in the fan section. And then I get the 16 degrees in the supply air. This also affects the way that the SystemairCAD work and how we input temperatures in the system. We are used to the situation that the temperature after the coil is equal to the supply air temperature. But that is not true anymore, especially when the heating and cooling capacities are placed in front of the fan. So we added a couple of new fields. First, in the default values, you're able to define your supply air target temperatures. Winter 22, summer 16 in this case. So here I can set up the default temperature the system will use whenever I create a new unit, and remember to press Save as Default. Under Unit Data, I can see for the unit that is active that I selected 16 degrees, summer, winter 22. And if I calculate this, I will also see that the resulting temperatures are here in the middle of the result field, 22 in winter, 16 in summer. If I want to change it, I have to go back to unit data, change for example to 14, calculate again, and I would see that my temperature in the supply air is 14 degrees. If I check my cooling coil, I can see that my temperature after the coil is 13.5. And then the fan is heating up to 14 plus half a degree. Let's look a bit at the printout. Let's print out unit number 2. I calculated that one full technical specification, no front page, print and preview. So this is the supply air fan, and let's zoom in a bit. And here we can see we added a couple of lines. So we have a winter temperature before and after the fan section, 21.5, 22, and summer temperatures 13.5, 14, and the corresponding humidities before and after the fan section. Let's also look a bit at the front page of the unit. Here we also did a couple of upgrades and added new unit data. So if I zoom in a bit, up here in the header of the isometric drawing, we can see that we added what delivery option is selected. If we zoom a bit to the table below, we can see that we placed the measurement unit right next to the values. We also added new information about selected unit color, hygienic option, and control system. And we also added information about supply air temperature, humidity, both in winter and summer, all to give a better overview. This new way of defining temperatures in SystemairCAD also means that if you open a file done in an old version of SystemairCAD, you need to be aware of the temperature inputs. If, for example, the heating and cooling capacities are placed in front of the fan, and you just open this quotation that is created in the old version, then you will see that the temperatures will actually be 22.4 and 16.4. That's because I have a 0.4 degrees heat increase in the fan section, and I defined the temperatures as being 22 after the heating coil and 16 after the cooling coil. But this is not true anymore. So to get the right supply air temperature, I need to delete the temperature after the cooling coil, delete the temperature after the heating coil, and make sure that I inserted the right supply air temperatures in the unit data dialog. So now if I calculate, then I would see that my temperature supply air will be 22 during winter and 16 during summer. But this will of course only be the case when heating and cooling capacity is in front of the fan section. If they are placed after, then it will still be the correct supply air temperature in summer and winter. So this concludes my small demonstration video of the temperature increase in the fan section and the new input dialog and how to define supply air temperatures in SystemairCAD. Thank you for listening.